Principal Developer Relations Engineer at Dash0. I'm also an OpenTelemetry Community Manager. And today I have with me Mauricio Salatino and Laurent Boudou, and they're going to dive into testing and observing agentic applications with OpenTelemetry, Microcks, and Reshapr. Before we start, if you have any questions throughout the presentation, feel free to drop comments. If you're watching on LinkedIn or YouTube, drop the comments and we'll ask the presenters. So don't worry about interrupting them. And we look forward to hearing more about what you have to ask. Now, Laurent, Mauricio, I'm really glad to have you both here. Let's start with some quick intros. Mauricio, let's start with you. So who are you? What do you do? And what are you working on right now?
Great. Yeah. So name Mauricio Salatino. I just recently joined Dash0 as an ecosystem engineer, and I'm doing a bunch of different things. Like I'm doing like AI observability, trying to understand again like semantic conventions on the OpenTelemetry side of things and frameworks that are basically being used to create agents, agentic applications. So I'm very interested in that space, and that's why I'm working here with Laurent. Laurent, please introduce yourself.
Yeah, so hi everyone. So my name is Laurent and I'm working at Postman. And at Postman, I'm fully dedicated to the open technologies and the open source project. So I was mainly involved into Microcks this last 3 years. Microcks is a CNCF project for 3 years, and we just reached the incubating level. And now for a few months, I'm building something new. I'm building a new project, a new open source project called Reshapr.
Awesome. Cool. So I'm going to give you both the stage. You can start. I think you're going to share your screen and show us some cool stuff. If we have questions, I'll try to interrupt you in the right moments. But yeah, please feel free to start.
Yeah. Let's do it.
So I'm the one who will share the screen. And yes, here it is. No, not this one. And here. Okay.
Yeah.
Is it clear? Yeah.
Yeah. Looks looking good.
Perfect. So this session is about, as it was said before, testing and observing Spring AI application, Agentic AI application. So the one connected with MCP servers typically. We both introduce ourselves. Here are nice pictures, and maybe let's go deep down. Presenting the demo application.
Yeah, we don't have enough time, so I think that we will just use this application to showcase a couple of things regarding the Spring ecosystem. We're going to talk a little bit about MCP servers and, of course, like observing AI and connecting, applications using the MCP protocol. So let's go and take a look at the application. It's easier than this like architectural diagram. So the application is basically like a store. Imagine like you have a chatbot where you can just buy stuff into a store. In this case, like it's a merge store for the Spring ecosystem, and the store basically has socks, stickers, and T-shirts. So you can actually ask the chatbot, for example, show me all the socks available in the store, and what it will do, it's going to go to the inventory, pick all the socks that are available, and in this case, use a tool to render each sock like icon in different ways, right? Once you have these cards, you can basically go and select different socks. In this case, the Spring Boot socks, and we can select another one if you want. But you select as many as you want. You can chat with the application to remove things from the order. But when you're ready, you can basically say, yes, I want to proceed with the order, check it out, and ship it to me to my address, right? So the idea is that we are creating a very, very simple application that it's using an LLM. In this case, we are using Anthropic to basically create an application that can drive itself, right? In this case, we are getting kind of like some notifications back, some asynchronous notifications back from the shipping service that basically is delivering the order to our door. So you can see here these bubbles popping up saying, my order was being delivered, like it's in transit, and then it got delivered to my home. We wanted to create something super, super simple, but because there is an LLM involved and there is like a SaaS service in this case, things get complicated, right?
Yeah, they always get complicated. Yeah. So And so basically the first thing we wanted to improve is the developer experience, about how to understand all the things that are going on under the hood, and how to be able to test that easily on your machine, right?
Yes, and the first thing that we did is we basically plugged in, we configure Spring Boot to send OpenTelemetry information to the OpenTelemetry collector, which is this like OpenTelemetry project provides a collector that allows to get a lot of telemetry from different applications and route that to different backends. In this case, we are using -0, of course, as the backend, so we can actually go and see all the metrics, all the traces, and the logs that the application is sending. We tried that first with Spring Boot, but then we started using a project that's called Arconia that gives us some flexibility on how do we configure and send, some more information about our AI applications. So in this case, what Laurent is showing is all the logs from the applications that we are getting from the interaction that we just did. But we can go and take a look at the traces, right?
Yeah, exactly. So traces, yes. We've got all the traces, and we can have a look at this one, for example, the streaming chat endpoint.
Mm-hmm.
We can have access to all the full traces here. You can see that we have a full graph here of dependencies and a full children spans everywhere. Let's say it's a very deep tree of spans, and we can see that different components are being involved here. Okay.
Yeah.
One nice thing we can see is that we have this small here diamonds that allows us to show that this span is associated with log records. And so typically, if I click 2 times here, I can get access to the log records. So here, during the interaction with the LLM, we know that we have different attributes, different logs. So here we can see there are the different attributes related to GenAI stuff. And we have also the different log records. So typically, we can also switch to the log view.
Yeah, kind of important to know. Yeah, kind of important to notice that we are looking at the trace view, and we can actually go from the trace to the logs. And in this case, the logs basically are showing us, by using semantic conventions, some of the prompts that were sent to the LLM and some of the completions, which are like the answers that the LLM is sending, right? And by just doing that, you have the flexibility to understand actually what's going on in your chats inside your applications, right? You are using now the GenAI filtering there, right? That will filter all the GenAI properties that were sent into these spans, which this is automatically done in this case by Arconia, which is decorating some of the spans with all the semantic conventions for making this easy to consume.
Yeah, exactly. So it's worth mentioning we have integrated in the demo the Arconia project from Thomas Vitale, which is really super cool and helps a lot in setting all of these details regarding the OpenTelemetry support in Spring Boot application, let's say.
Yeah. And finally, when you move to the logs, right? The next step usually is to, when you are in the logs, one of the things that you can do is you can look into, for example, hover the resource. The resource in this case is the service that is basically emitting these logs. And what you can do, as Laurent is showing, you can see actually go to the metrics now from that specific resource. Now what we are seeing is the metrics from the store service filtered by the resource ID, which basically will allow you to troubleshoot things like, there's a garbage collection issue, there is a memory issue from the application, so that might be causing issues as well. And in this case, we don't have any failures, which is fine. But in the case that things start popping up, you can create alerts on all these metrics. And then whenever something goes wrong, quickly troubleshoot and find and pinpoint the cause of that issue by just moving around traces, metrics, and logs. Yeah. So hopefully that makes sense. Yeah.
That makes sense. And here, we don't have errors yet because we just restart the application before the beginning of the live stream. But we'll see in a few minutes, in a few dozens of minutes. Okay, cool.
So this kind of brings the question, right? Now we are using kind of a real LLM. We are calling Anthropic APIs, but sometimes developers do not have access to that, right? So what can we do in that case?
Yeah, so sometimes we don't have access, or sometimes it costs too much. Or
That's true.
sometimes also it's really, really slow, because you may have noticed that each and every time I'm typing and I'm setting orders to the application, it takes some time
It's
to
a couple of
serialize
seconds, right?
everything.
Yeah.
Yes, a couple of seconds to send the context to the LLM to get the response back, and so on and so forth. So let's imagine having this in a CI/CD pipeline, and you absolutely want to have a very quick feedback loop. That's not very cool to have this LLM here in between. And so one thing we can do if we want to, let's say, speed up things, and if you want to spend less regarding LLM tokens, is that we can cut these dependencies. And that's what we are going to do actually. We, instead of using this Entropic API, we can use simulation mocked response so that we can speed up the feedback loop when testing non-LLM areas. Because sometimes in your application, you have an AI-infused application with some LLM-related features, but you still have a bunch of other features that may not be directly related to LLM, and you actually want to have very quick feedbacks on it. And so that's where Microcks enters the stage and can fit in the picture. So what's Microcks? Oh, I should have updated this. We are
That's
no longer a
yeah.
sandbox.
There you
We are
go.
incubating.
There
So
you go.
so Microcks is a project that, in a nutshell, turns your existing API or services artifacts into lightweight and smart simulation. So typically, we are starting with all the different assets that may already exist in your organization. So it could be Open API specs, it could be gRPC protobuf services, GraphQL schema, it could be also SOAP UI project or Postman collections or whatever. And from all this information, Microc is able to generate mocks on the fly without having to code anything. Okay, so just by discovering the schema information, the example fragments you put into those assets, it is able to provide smart simulations on the fly. So as an API consumer, I can start working with this API, but also as a dependency that relies on this API, I no longer have to wait for a sandbox environment to be ready. I can use Microcks and I can use it locally on my desktop, integrated into my application. Nice.
And at the end of the day, right, like an LLM is just an API, right?
Yes, exactly. So here, what we propose to do is to just reuse the Anthropic, the OpenAI, any LLM API, and to use Microcks just to simulate those interactions with the LLM in order to cut dependencies and speed up things. Okay. So typically what we are going to have is this configuration. Instead of having the store talking directly to the LLM, we will have the store talking to Microcks, but it will be totally, let's say, invisible for the application. So let's demonstrate how it works. Okay, so let's move to my VS Code. So here, I'm gonna cut the application that was running, let's say, in production mode, and I'm gonna start it in dev mode. And in order to integrate Microcks, but also all the other dependencies that my application needs, so typically it needs a connection to a Kafka broker to get back all the events coming from the shipping component. I am using a Spring integration with the test containers library. So if you don't know yet test containers, go check for it. Test container is really super cool. And so typically in your Spring configuration, you can just create a Kafka container on the flight like this, okay, with a network alias being associated this way, and with a service connection annotation that allows you to wire up your Kafka container within your application transparently.
Yep. So it's like a more, it's like a cooler way of creating Docker composes in a programmatic way where you can coordinate all these containers.
Exactly. And you have this directly integrated into the Spring ecosystem with all the all the annotation, all the different flavors of Spring. So that's super cool. And so you can see that we are doing exactly the same thing for Microcks. Microcks as a Microcks container. Okay, we are associating it with the same network. And what we are doing here with those two lines here, with main artifacts and with secondary artifacts, is that we are feeding Microcks with the Entropic OpenAPI spec, so that it will be aware of the different operations of the chat system and so on. And we can also feed it with secondary artifacts. Secondary artifacts will typically used to provide Microcks with canned response. So you can provide simple YAML files. You can also provide a recording of live traffic. Imagine you have an existing API and you have put a proxy, an envoy proxy in the middle. You can record the traffic, and then you can feed Microcks with this recording so that it recreates a full sandbox that simulates your target endpoints. Okay.
Amazing.
Yeah. And here, just those two lines are to connect Microcks with the OpenTelemetry exporter. Simply put.
Yeah. With the collector, yeah. So basically, even Microcks, like with the canned response, will be sending telemetry, so we can understand what's going on in the.
Yes, because even if we are using mocks, it's still very important to understand why this mock response was sent by Microcks instead of another, and so on. So there is also another important part here. We use the Spring ecosystem and typically the dynamic property registrar typically to override at runtime the Spring AI Entropic-based URL. So this URL is typically used by the Entropic SDK. And here, instead of using the Entropic provided endpoint, we just say that, hey, retrieve the mock endpoint that is provided by Microcks for this Entropic API in version 0.83, for example. And so here, transparently, the Microcks mock endpoint will be wired to your application without any other changes. So that's super cool.
That's really cool because basically, again, you're making it super transparent for the application, right? The application, when runs in production mode, it runs with Anthropic, right? But when you run it now in test mode, it will just use the Microcks endpoints instead.
Exactly.
No changes in the code, just changes in the configuration of the test.
Yeah, sure. So here we are going to run our application in test mode, test run, and we are just putting here the JVM property to say, hey, I want to enable Microcks, okay? So starting here, and it will launch a bunch of containers. Oh, yeah, by the way, it rebuilt also the UI, but that's it.
Yeah.
Okay. And it's good and it's ready. So getting back to my application, I can restart it, refresh it, yes. And here I can say, hey, I want you to list all the items. And I can send it and get a response immediately. Yes, exactly. So here you can see how it accelerates the testing process, and all of those things can, of course, you can use them to realize some end-to-end tests using the UI, but you can also use them to write unit tests in JUnit. So it's really cool. So all your interactions with the LLM will be directly and transparently mocked.
And I totally see that, right? Like I totally see that, like people recording the LLM interactions so they can use that like a scan response later on, right?
Yeah, sure. And that's the point, because instead of testing so many time and waiting for, let's say, hallucinations or edge cases to appear, you can use the mock canned response to to be more deterministic and to directly test the edge cases and so on.
Yeah, exactly. Yeah, so you can actually generate something that will trigger an edge case. Yeah.
Yes, exactly. So let's look at the traces, and you can see all traces. And here I have a Microcks test right here. Oh, and yes, this one typically, yes. So looking at the full trace on the Microcks side, you can see that it has processed an invocation, okay, and you can see that we have some logs here. So here, typically, yes, invocation was received. We found the valid operation, that is one operation coming from the Entropic API definition, okay. And now we are looking for what we call in Microcks a dispatch criteria. That means for each and every incoming request, it tries to compute and to apply some logics so that it will be able to retrieve and to send back the most appropriated response. Okay. And so typically here you can see that, yes, we have a compute dispatch criteria. We use the dispatcher that is actually a small JavaScript snippet. And we find that the canned response we need to answer is the list inventory response. Okay. So simply put, this is how Microcks is working before, yes, sending back a response to the caller of the API.
Yeah, and just to sum up that, like it's basically you added Microcks to the application, so and you pointed Microcks to the open AI specification plus some canned response, and then you need this kind of like a small script that basically by looking at the input will decide which output to send, right?
Yes, so it really depends, in fact, on your business logic, let's say. So if you have something if you provided a lot of examples and you have something that is quite simple, Microcks will be able to infer the dispatching rules on its own. Okay, it will look at the URL params, the query parameters, the headers, this kind of stuff, and it builds a dispatch criteria by itself. Here.
Perfect.
Things are a bit, let's say, not complicated, but much more complex. And typically, we wrote a snippet of JavaScript to be able to handle this logic. And so typically here, we have also access to the Microcks UI. We can see that the Entropic API is mocked, is provided. And we have here just provided samples for the post D1 messages. And you can see that we have mocks for listing inventory, for finding by price, for finding cheapest items, for finding items within a range, this kind of stuff. So
perfect.
Obviously, the most you want canned response being similar to, let's say, a real production system, the more mocks you will have to provide to Microcks, and maybe the more complicated will be the dispatching rules. But yeah.
Makes sense. Yeah, that makes sense. I saw something kind of like if you go back to -0. So I think that it's important to mention here that we are looking at the Microcks traces that in this case are not part of the application trace, right? Like they are like, for some reason, they are not linked, right? So maybe you can show the chat trace, maybe if we can find that.
Yeah, maybe we can see service name.
Store.
Yes, here, API chat.
Yes. Yeah, exactly.
If
you go to that trace, what you will see is that we are calling, what does it show? It shows that we are doing like a call to an LLM and we are then doing a tool call, right? But we don't see that correlated with Microcks. And we were thinking like, well, this should be correlated because actually we are propagating the context and Microcks is picking up the trace, the incoming trace parent ID and doing its thing, right? Until we found that, the Entropic SDK doesn't do that for now.
Yeah,
so
exactly.
We are waiting for that fix to pop up, and then you should be able to see like how from that LLM call Microcks is responding and sending the payloads back, right?
Yeah, yes, exactly. And in fact, we were a bit disappointed. We we scratched our head a moment because yes, exactly, because some weeks ago when we talked together at Spring I/O events, things were working because the Entropic SDK has this integration with the REST client customizer in Spring. And we were able to configure this trace propagation stuff and having this link from Spring AI client to Microcks. But since the 2.0 Mython 3, this is now broken because Entropic SDK has switched to another HTTP client. So yes.
So we're waiting for that fix. We created a pull request and everything. So I think that's a known issue.
Yeah.
So we need to wait for that to get fixed. And whenever we get that, we will definitely upgrade the example.
Exactly.
So with that, we cover, I think, testing. Probably the next step is just to talk about the MCP, right?
Yes, exactly. So we covered the testing part and how to have, let's say, a better developer experience. But now the thing is how to wire your tools to existing APIs with MCP. So what we want to achieve is this architecture where the store component is talking to the shipping service that is an already existing, let's say, third-party service written in Go and providing gRPC service. And we want to interact with an MCP server that is doing the translation for the Agentic store here. Okay.
Yep.
And this shipping part will send back notification using Kafka.
Yeah, and by just looking into that, right? Like now we have three other things to monitor with very different interaction patterns, right? Like now we have the store service that is probably interacting via HTTP with the MCP server, right?
Yeah.
And then doing some sort of a bridge to gRPC, and then the Go service will be sending Kafka messages via Kafka broker that will arrive to the application backend that will be forwarded using WebSockets to the frontend, right?
Yeah, exactly,
So
exactly.
A lot of moving pieces and a lot of different protocols, let's say, and a lot of different, envelopes.
Yeah, sure. But first things is to say how to provide this shipping MCP server in the middle. Yes. So you want to write this one, and obviously, you have everything provided into the Spring AI ecosystem. You have protocol adapters. You have annotations. So it's really easy to start to write Java code and build this little proxy in the middle to expose MCP and call the gRPC service. But now imagine that you have an existing backend and you realize that the component you're writing here, it's actually a lot of boilerplate code, okay? It's just a notation, REST client or gRPC client manipulation. It doesn't have a lot of, let's say, value from a business perspective, okay?
It's just a bridge, right? Like it's just a
Just
bridge
a
that you will
bridge.
need to maintain forever.
Yes, exactly. And moreover, it requires you to become an MCP expert, but also a network proxy expert, security expert, because you want to secure the whole invocation chain, obviously.
Yeah, makes
And
sense.
so you may tend to think that, yeah, but now we have AI, we have Cloud Code, we have Copilot, so the two first bullets are really easy to solve. We can ask Claude to code for us, but at the end of the day, you'll still have an additional component that you want to deploy, that you need to deploy, that you need to operate, to update each and every time, and a component that will consume a lot of resources. So that's why we choose another way for doing this, and that's where we can introduce the new project I'm working on that is called Reshapr. And yes, basically, you have understood that this approach doesn't scale. It's not sustainable at scale because you'll need a lot of resources. You'll spend a lot of time deploying new component and managing complexity. And so that's where Reshapr entered the game. And basically, Reshapr, I wouldn't say is very similar to Microcks, but we use the same foundations of Microcks. That means we are able to ingest OpenAPI spec, GraphQL schema, gRPC product buffers, and do the translation and provide an MCP server on the fly. So you don't have to generate anything. Reshapr don't generate anything. It just computes translation on the fly to provide enterprise grade and very efficient MCP servers. Okay.
Perfect.
And when we say Reshapr, it's because it's actually reshaping API to MCP. What we don't want to have is to have the one-to-one mapping between an API operation and an MCP tool. We want something smarter that we can really adapt to the business use case we want to address with the Agentic component or the new agentic workflow we are building. So typically, Reshapr is able to do a lot of things to bridge those two worlds of API and MCP design. So it can rename API. You can pick and choose each and every operation you want to translate as MCP tools, but you can also enrich your MCP with custom prompts, with resources, also with MCP apps, this kind of stuff. So you are really able to build a full-blown MCP server. On the transformation side, you can simplify the interface, you can condense things, change the granularity of operation, you can filter out the results because sometimes it makes no sense to send back all the objects. You want to trim down so that you can also reduce the number of tokens before rating the LLM, and you can change the format of stuff. Typically, we are supporting the tune format.
Perfect.
And the last point is that Reshapr allows you to produce secure MCP endpoints and to manage all the things related to the API backend authorization. So here we are managing protocols and specification standards like OAuth, obviously, like SPIFE, like CIMD. We are managing things like through elucidations, for example, so that your LLM and MCP client in the middle don't need to be provisioned with backend secrets. So we're really here to adapt the API to the agent needs, okay? And
Perfect.
give you a very fine control on the context.
And that provides also like access to observability at that layer, right? So you can actually monitor what's going on between the components.
Of course, yes. This is really part of what we call the enterprise grade MCP server. Okay.
Perfect. Yes. Let's see it in action.
Yes. Maybe in a nutshell to introduce the demonstration. Just explaining, we have two main components in Reshapr. We have a control plane that is holding all your service definitions and policies. And we have a very lightweight proxy that can be deployed anywhere, maybe in a very hybrid way. Okay, it can also be deployed as a sidecar container right next to your application if you want. Okay, and when it starts, the proxy just point to a control plane. There is this secured auto discovery mechanisms, and then it retrieves the exposition policies, and all the changes you apply to MCP server are directly streamed down to the proxies. So it really allows you to compose very flexible, very dynamic and multi-tenant architecture.
So when I think about this architecture, I think about like that, like you are controlling like a fleet of MCP servers in a way under definitions, right? So, and you're providing like all the cross-cutting concerns for those servers themselves. So like, you know, like the one that is in charge of deploying all these things, they have a tool to manage all this complexity.
Yes.
Very specific to the MCP serving.
Yeah, totally. So it can be really transparent for our application developers, just putting an annotation on your pod. And then you will have a Reshapr proxy that will bring you observability, security, and that will convert your API into MCP.
Perfect.
That's it.
Well, exactly what enterprise large companies need, right?
Yes, exactly. So maybe we are going to shut this and go to the demo. And what I'm going to... So here I have the Reshapr service running locally. This is just Docker containers, okay? And what I can demonstrate is how easy it is to create actually this a new MCP server. So here I'm logging to the control plane, and I can ask what are my services, Reshapr service list. So here I have one service here, and I'm gonna delete it. Service delete and recreate it from scratch. So
perfect.
Here you can see I delete this service, and that's
that was the shipping service that we used before for running the demo, right?
Yes,
that's the gRPC. That's the gRPC bridge from MCP to gRPC.
Exactly. Yes, and I can recreate it very easily. Just saying that, just use this file as a reference. Here it's the protobuffer definition of my gRPC service.
Can we take a look at that? can we take a look at
Yes.
how the proto looks? Because the proto will have kind of like the interface of the service, right? So it have
Yeah.
all the operations that the service has.
Yes, exactly.
Um,
So
and
here
the
you
data
have
types.
the
Yeah.
type definition, and you will
Mhm.
have here three
Mhm.
different operations: ship order, ship
Yes.
delay, shipping fail. Okay.
Perfect.
And so it's just a simple import. Here
Mhm.
I can say that the backend endpoint to use will be the locally running shipping container. And here I want to turn on the audit feature, and
Okay.
that's it.
Okay.
And
And
I have here a simple MCP server that is already running here. Simply put.
perfect. So now I can point my application to that MCP server to start using tools
Yes.
from that server, right?
Yes, exactly. I can connect using my MCP client. I can have access to the different tools right here. Very simple.
Perfect.
Very simple. So now I can start my application again.
Let's do
So
that. Yeah.
here, this one.
Maybe you can quickly show, like in Spring AI, like in the properties file, where are you pointing to the MCP server, right? Because we need to tell the Spring AI application where the MCP server is, so it can go and
Yes.
fetch the tools.
Yes. So its store is in resources,
Resources.
application. So
Yeah.
here
There are a
you
couple of
just
properties for that, right?
yes, exactly. So here you just
Mhm.
say it's locally running, and this is the endpoint that is provided by Reshapr. Okay,
The tools. Perfect. Yeah, that's good.
exactly. So now getting back to my application,
Mhm.
I can run it once again, saying yes, I will use the same things. Show me
Yeah, show me the
the
socks.
socks,
Let's see.
and we will then deep dive into the traces. So adding this to the order.
Mhm.
Yes, please proceed with checkout and ship it. Proceed. There
There you go.
you go. So here, thinking, the order is placed.
Mhm.
And yes, I have a second shipment that is pending, that is shipped, and
Mhm.
that will be delivered in a few seconds. Okay, cool.
Perfect.
And so I can get back to traces and inspect the traces a bit more. So it's 5 minutes. All
You have a
traces.
filter
No.
there, yeah.
Yes.
There you go.
Okay. Cool. This one. So
Mhm.
typically, this is the one that is interested. I started in the store component. Here, I called the Reshapr MCP server. You
Mhm.
see that under the hood, I'm doing the translation, and I have a gRPC service that is calling the shipping service. You can see
Mhm.
now I have the purple here bubble for the shipping.
Mhm.
And we are shipping the order, and we are sending three different events on Kafka. And these events are actually processed by the
By the
store.
store. Yeah.
And
So you can
that's
see
cool.
the full loop, right? Like you are sending messages via MCP to the shipping service. The shipping service is sending Kafka messages, and those Kafka
Yeah,
messages are being consumed by the store.
exactly. Exactly.
Yeah.
That's super cool. You have full end-to-end observability on what's going on because all the different components in the chain are using open telemetry.
100%. And yeah, go for it. Do you want to add
Yeah, no,
something?
typically, yes, going to, yes, show the different attributes of the span because here you can see that, yes, you have access to the route that was called. My MCP server was attached to the default Reshape organization.
Mhm.
It was this service, Spring IO Workshop shipping service, this version of this service. So here you have also the full trace of what has been called on the service.
Perfect. Yeah, that's really cool. You mentioned something about the audit log as well, right?
Yeah, exactly. So we have an audit log, and
Uh-huh.
typically, uh, all this audit log is also transported using OpenTelemetry. And so typically, if I'm looking here at the audit log, I still have access to the Reshapr here, audit. So I know the tool calls has been called, the outcome was a success, I get the
Mhm.
duration, and I've got all the information here. So typically, I am also able to have the source IP of the caller if the color was identified, I have the identity, and I also have the trace ID, so I can circle back and get access to the full trace that produce this successful call.
Exactly. So that's a tool call, right? That's a tool call going through Reshapr, and basically you have the trace parent ID for who made that call, right? So you can actually go back and say, okay, show me kind of like the application that made this call through the MCP server.
Yes, exactly. So you can say here, if you want, copy paste the trace, let's say, and here, just pasting. Yes.
There you go.
You got the trace, and you have the full explanation. That's cool.
That's really cool. That's really cool. And yeah, and I think that like now what we can do is we can be a little bit more evil, right? So we created kind of like a couple of things to see what happens, right? Like what happens if you have like a tool that is taking too long, right? So we have that button that basically will send a prompt to make an MCP tool call that it's going to, take like more than 10 seconds to execute.
So yes, so let's try this out. Let's try to see what it means to having a shipping delay. And here we can have this approach of that's one of starting with the audit log. Let's say on the audit log here I have warning. Okay.
What happened?
This was a failure. The duration was 3 seconds, and I can get access to the trace ID. So here I can get this one, get to the tracing, and saying no, it's not set, and just copy paste.
Just paste it there,
Fat fingers. Okay, and here I should have this one. Yes.
Oh, I see something red.
Trace. Yes. And here you get some red stuff. And typically, you have also the integration with the logs we see earlier. And we have here the explanation. The call deadline exceeded after 3 seconds. Okay. And we have the whole spectra if we want.
And as you can see, this is Reshapr basically telling you, hey, your tool call took too long, right? And it's automatically like just retrieving an error. Okay, interesting.
Exactly, because we have a default policy that applies here that says that the backend timeout should not is 3 seconds, but we can change this, obviously.
Okay.
So let's see how we can do this. So when we imported our services previously, Reshapr also created what we call the config plan. Okay, the config plan is a configuration on how to deploy this. And what we can do here is just update this config plan. And so we just say here, and you can see it's very easy. And I can just here update things and add more attributes and more complex policies. So here I can say that the backend timeout. So I would say it's 10 seconds. So I would say let's
12.
Rule 12, yes, like this. And I can just save this.
Okay. And that was applied?
Yeah, it is saved on the control plane. And so it is pushed, it is streamed to the different proxies that are exposing this service. And so now, if I'm getting back to my application, I can see, and I can say, yes, shipping delay, that's it. So we have to wait at least 10 seconds. Getting back to maybe the logging, the audit log. Say last 5 minutes. And yes, now we have a success.
We have a success. Perfect.
Yes, because we now the timeout is not reached, so it applies as a success.
And I think this is good to keep control on kind of like the backend APIs that you are calling, making sure that you have proper timeouts across like all your MCP servers, all your MCP calls, right?
Yeah, exactly. And you can very easily drive everything through policy configuration using the config plan on the Reshapr control plane. Everything will be redistributed automatically to the different proxies.
Can you go to that trace? I'm really curious. Can we take a look at the trace?
Yeah, look at the trace. So here I can, it's here in the attributes. Give me the trace ID, going to the trace. I don't know why.
It's just paste. Yeah, I think paste and enter, I think. But it tries to add a filter, right? Yeah.
Yes.
There.
So maybe I should say trace ID is one of, yes, comes like this. Okay.
Yeah.
So
Perfect.
So here I have the full trace.
Yeah. I want to see that, like, so the shipping span. Yeah, so it's 10 seconds, right? So you can see there,
10
like,
seconds.
yeah,
Exactly.
if you show the flame graph, I think that like in the flame graphs you will see it. Yeah, that's a long span there. Perfect. And everything blocks, right? Like Reshapr needs to wait for it.
Yeah,
And then finish.
exactly. And you can see by the way that here, the overhead of using Reshapr is actually super lightweight. Here
Is
it's
it 27 milliseconds?
13 milliseconds, the difference between 27 and 14. Because it's just translation on the fly with the application of the different policies, but it's just 13 milliseconds here.
And just to remember people, what we are translating is like an HTTP request from the LLM to Reshapr to a gRPC call that is using
Yes,
protobuf,
exactly.
right?
Yeah, so we are also doing the JSON to protobuf back and forth. Yeah, so that's cool.
Pretty fast, actually.
Yeah.
That's pretty cool.
Okay, we can also send some failures, but
yeah. So we had an issue. This is basically calling a tool that throws an error, right?
Yes, and so basically it will be the same. Let's say the same approach. We have a tool call here on chipping failure. The outcome is a failure. It was super fast. It failed. It's super fast, but we can have access still to the trace and then deep dive into the stack traces, into the log and so on.
Perfect. Yes, trace ID.
Yeah, I don't know. Maybe I've had fat fingers at the end of the week. Yeah. So yeah, here and we have yes.
And you see the traces, right? Like the nice thing about like Dash Zero, because I'm also like I've been using it for a month, is like that you see when something goes wrong, there's a red dot somewhere that you can just quickly follow, right?
Exactly. You have events and logs right here, so you can view in the logs or view here in line. So that's super cool.
Perfect. Yeah. I think that's super cool. And I don't know if you know, but like if you type Command K, right? So with that window open, type Command K.
Command K, yes.
And then and you can ask like what's happening, right? Like you can ask like what's happening in this trace, and Agent Zero will try to explain you and find the issue in that case, right? In this case, we made the shipping service fail, right? But the interesting approach about this is that sometimes you actually don't know how to troubleshoot or where to go to find the issues. And now you have this tool in Dash Zero that will help you to pinpoint kind of like the issues there. So that's pretty cool. Cool. I think that we have demonstrated a bunch of different things, right?
Yeah, sure. Yeah, so here, it explains as an error status. Okay, cool.
Yeah, it's still investigating. It's going to do the analysis. Yeah, there you go. And it will explain the architecture of the app, right? Like it will explain that it went through an MCP. It gives you the trace.
Spring AI processing, backend gRPC call, so everything is explained correctly.
This is probably telling you that the Microcks is that Reshapr is pretty fast as well.
Yeah.
Amazing.
Cool.
Great. Let's go back to the slides, right?
Yeah, okay, let's wrap up things. So what we demonstrate here is that we were able to make the complete system totally understandable. So we can get the traces, the metrics, the logs from each and every component in the architecture and have a, let's say, full monitoring of what's going on in the application.
Yeah, and we have like full connectivity with MCP now, right? So by just adding Reshapr into the picture, we can bring services that already exist and connect them to LLMs pretty easily.
Exactly. So exactly in a few seconds, in a few minutes, if you want to configure all the different policies, you have this ability to build MCP servers really fast. Most of the time, one thing that's really nice is that you don't have to code anything. I would say that the most advanced things you may have to produce is YAML files, like this one, for example, where you can define custom tools, and you can say, for example, these custom tools will reuse the GitHub GraphQL API, and it will have a specific dedicated tool name with a specific input interface, but under the hood, it will reuse another existing tool that is provided by the GraphQL, the GraphQL API, and that's it. That's the most complicated stuff you have to produce with Reshapr, and you have MCP servers in a few seconds.
And I think that's quite a common example, right? Like something like GitHub APIs will have tons of different endpoints, right?
Yeah.
And you don't want to provide every endpoint as a tool. You probably want 2, 3, 4, 10, but not like the 7,000 endpoints that they provide.
Exactly, and maybe you want to provide a tool with just a read-only operation, because the official GitHub MCP servers have like dozens and dozens of operation and read-write operation. Everything is mixed in. Here you can really build tailor-suited MCP servers in a few seconds.
Perfect. Yeah, amazing.
Perfect. Yeah, and I think that's a wrap-up. Yeah.
It's a wrap-up. There you go. What have we learned?
Yeah, so the first step was that so we can use mocking to and also contract testing, but that's another topic, to cut dependencies and to provide very fast feedback loops. Also to cut the cost of using an LLM for each and every unit test, each and every CI/CD pipeline execution. We've seen how Reshapr provides an easy, flexible, and enterprise-grade way for connecting your existing application and producing MCP servers on the fly.
Yeah.
Obviously, we put observability everywhere. Want to say a word on this?
Yeah, definitely. So I think that, like, for me, more than observability is that we used OpenTelemetry, right, for consuming all the telemetry from all the applications and all the components in the architecture, including Reshapr, which is also emitting OpenTelemetry, which is great. And we also looked a little bit into the semantic conventions for Gen AI, which I think it's like a field that it's evolving every day, right? Like there are tons of different tools creating different conventions. And in this demo, we showed like the OpenTelemetry semantic conventions for Gen AI, which allows us to get a lot of information about what our application is doing against different LLMs. And finally, as the last bullet point says, like you can run this example in your own computer without having a Kubernetes cluster even, right? And in the next slide, you can see the GitHub URL for the example. And you feel free to create issues, create like pull requests if you want to contribute to the app, or get in touch if you have questions about this.
Yeah. We try to have the most comprehensive possible README. So if you want to rerun everything at home, you should be able to. But don't hesitate if you have any questions. To reach out.
Awesome! Wow, this was really nice. It's really cool to see all the tools interacting together and helping each other. We actually had one comment before the live stream started from Keshav. He said, I think there's a real gap in understanding how these agents operate beyond just the build phase. Most developers focus on functionality, but overlook the crucial step of real-time observation. Without solid monitoring, we miss out on optimizing performance and understanding user interaction. And then he said, I'm curious how the panel will address those challenges during the webinar. And I think you two answered that pretty well today. So you can't improve what you cannot see. And especially with agents nowadays, this is even more true than traditional services. And the combination of OpenTelemetry, Reshapr, and Microcks, it gives you that visibility. Do you have anything else that you would add that you maybe didn't mention throughout the webinar?
I think that one thing is for sure, we will keep working with Laurent, building more complicated demos. This is like, for us, like, I think that my main takeaway is that we are building very simple applications and they are very complex already. So when you think about like enterprise-grade agentic applications, you will need more tools, more observability, and more flexibility, so you can create larger applications without the hassle of maintaining all that crazy things that you don't understand how they work. So I think that we will just keep building on that space. And MCP is like a very large field that still is in development. So we will keep an eye there.
Yeah, and one important thing I think at least we try to demonstrate is that all these things regarding operation monitoring, observability, and so on are not just for Kubernetes clusters and production. They can be integrated very early into the process. They did not break the developer experience. It's really easy to integrate them using test containers, using Docker Compose, and so on. They are very lightweight, so you shouldn't try to avoid them.
There is no excuse to use
No
Yeah.
excuse, as you say, yes.
Yeah.
Good
I
stuff.
actually have a question for Laurent. If someone watching this, if they wanted to contribute to Microcks or Reshapr, where would they actually start, or what kind of help do you need in those projects?
Nice question. So both projects are fully open source, fully community driven. So feel free to join us. You have microcks.io, reshapr.io. On both sides, you have access to the Discord servers, and we welcome help for anything. It could be building demos, it could be writing documentation, advocating, but also contributing. We have really a lot to do, still a lot of ideas to implement. So yeah, definitely welcome to anybody who wants to help us.
Awesome.
That's great.
I wanted to give a shout out to Guy. He's Guy Robert. He said clear presentation and cool interaction between Mauricio and Laurent. And
Thanks.
Yasmin said thanks, folks. So thank you all for watching. Thank you, both of you, for this amazing presentation. Looking forward to seeing more of what you built. And this will be available on LinkedIn, on YouTube. We'll post some shorts from this, and feel free to connect with them on LinkedIn and go to Discord and start helping more on these projects.
Excellent.
Awesome.
Thank you, folks.
Thank you.
Thanks a lot,
Bye.
Leah, for hosting us.
Take care,
Bye-bye.
guys.
Bye-bye.
Bye.
Take care.